Hi everyone, welcome to my channel, Maths Made Easy with Terry in 10 minutes. We'll be talking about parallel vectors here. Please make sure you review previous video because I'm gonna just talk about parallel vectors. I'll talk about some of the properties and introduce it, then I'll keep on building it up from there. Is that okay? So if you've not liked, shared, and subscribed, I don't know what you're waiting for. Please don't forget to click notification bell so that when I post new videos, you'll be the first person to know. Okay. So what are parallel vectors? These are vectors that have the same direction or exactly opposite direction. So what I'm saying is that these are parallel vectors. You can see they have exactly the same direction, or they're in the same direction, or you can have it like this. These are also parallel vectors because they're exactly what? In the same direction. Or you can have it like this when they're exactly opposite direction, but they are still what? Parallel vectors, okay? So, and also, we can take this a step further by talking about multiples, so scalar multiples. So for instance, you can say this vector here, okay, is twice this. So if this vector was k, this is going to be like 2k. That makes sense? So this vector, the magnitude of this vector is twice the other magnitude. And also another thing about parallel vectors is that there are no angle between them. So you can never see an angle. When we're doing the dot product and scalar product, the dot product, you see when we say a parallel vector a vector A and B, okay? And we're now looking for the dot product of A and B using an angle. But for parallel vectors, both of them, there is no angle between them. So theta is always equal to what? 0. And this is going to play a very major role when we're going to talk about the dot product of parallel vectors, as well as the cross product of parallel vectors as well. Then after this, I will also talk about some of the properties of parallel vectors. All right, so I'll talk about the properties of parallel vectors so that you can get conversant with it. You can know, okay, what are the characteristics of the cross product of a parallel vector? What's the characteristics of a cross product of a parallel vector? And if both products are parallel to each other, what does it imply or what are the implications? All right, so let's quickly, because I'm aware students do take notes, so I'm going to start writing so you can also have it so that when you're going back to revise, you can um, do that as well. So parallel vectors are vectors that have the same direction or exactly opposite direction. So you can have these vectors, these are parallel vectors. So these have same direction. Are you seeing it? Or you can have something like this. They're both parallel, but they're exactly opposite direction. So you can have it in the same direction or exactly opposite direction. All right, so we can take this a step further, all right, and talk about the multiples. So taking this a step further, okay, any scalar multiple of a vector. So here, any scalar multiple of a vector is parallel to that vector. Okay, So any scalar multiple is parallel to that vector. So for instance, if you have a vector A, so let's assume there, therefore, if a vector A or if a vector is A, all right, then vector KA, so where K is the constant multiple, okay, vector KA is parallel to A. So we're going to talk about this concept very soon in the subsequent video, the concept of KA, because there'll be some questions that they could give you two vectors and they can ask you, are these two vectors parallel? So basically they want you to find K, okay? So parallel to A provided K is a scalar or is scalar. So K has to be what? Scalar. So when we talk about scalar, we're referring to it to be a real number. Okay? And also, before we talk about the properties, I'm going to just talk about what is said to be the angle. I'm going to refer to the angle here. So just in case, if we're talking about parallel vectors, so you should know that parallel vectors, there are no angles between them. So there's no theta, okay? So finally, two vectors are said to be parallel if and only if the angle between them is 0 degrees. Okay, so 0 degrees. So if the angle between them is 0 degrees or is equivalent in radian, okay? If it's 0, then the two vectors are said to be parallel, okay? So if you look at this, now if you have a look at this one, these two vectors are parallel. There is no angle between them, even if they are scalar multiple. So maybe this is 3 times the height of that. Still, there is no angle between them. So parallel vectors in the same direction. So these are parallel vectors in the same direction. Then, so also you can also have parallel vectors in opposite direction. Okay? Or even though you have they are scalar, so you have this one, and maybe this is twice or 4 times that. So this is what we call parallel vectors in opposite direction. So this is what we call anti-parallel vectors. Okay, so this is what we call anti-parallel vectors. All right, so that is that. So parallel vectors, there are no angles, okay, and they could also be scalar multiple, and they could be either in the same direction or they could be in opposite direction, okay? So let's talk about the properties of parallel vectors quickly. So let's talk about the properties of parallel vectors. And then we'll now talk about how to find parallel vectors. We'll talk about the dot product and the rest of it. So we're going to talk about the properties first. So number one, the first thing you need to know is that two vectors are parallel if and only if there is a scalar multiple, okay? So if both of them have a scalar multiple, so two vectors A and B are parallel to each other if and only if A is equal to what? KB. All right, so where K, so if A is equal to KB, so where K is equal to scalar. So we're going to talk about how to find parallel vectors very soon. And this is the concept that you need to know. So that means when you equate both of them, they have to be a scalar quantity. So for example, you can have A and B could be like 3/4 of B. So that makes sense. So they must be a scalar quantity that relates both of them together. So we'll talk about this, don't worry. We're almost there. Then the next one as well is for number two, is that two vectors A and B are parallel when if they're in the same direction, K must be greater than 0, but if they're in the opposite direction, K is going to be less than 0. So number two, if two vectors, take this a bit, okay? So you have if two vectors A and B are parallel, the vector direction will be, okay? Now, if it's same direction, so if they're having same direction, it will be same direction if K is going to be what? Greater than what? 0. So when you solve it and you see K is greater than 0, so it means that they are parallel in the same direction. So that means you should be expecting, you have something like this. So this is A, and something like this. This is going to be B. So they're in the same direction, but they could be of different magnitude size. It does not really matter, but it means they're in the same direction. But the next one, they are in opposite direction. If K is less than 0. So when you solve, you're checking if they're parallel and their K is less than 0, it means that they're in opposite direction. So if this is A, then you could have this to be what? B. So they're in opposite what? Direction. So you have to keep this in mind. So let's go to number three. So the third one, the third property is that it's been said that every vector is always parallel to itself, sorry. So every vector A is parallel to itself. So that means technically the K here is going to be equal to 1. So does that make sense? So that means a vector A is going to be 1A. So that means the K is equal to 1. So that's what you need to know. So that means you have, if this is A, then the other vector as well is going to be A. So it's always parallel to itself. Now the next one is in terms of cross product. So in the previous video, I've discussed cross product, and I've showed you how to get a cross product for a 3-dimension and a 2-dimension. Okay. So it's very important you go back and you have a look and see it for yourself. So, but when remember that the angle we talked about, that there is no angle, the theta for cross product. Okay, so the theta between two parallel vectors is 0. So that means the angle between two parallel vectors is 0. So therefore, when you find the cross product is going to be 0. Okay, so two vectors, A and B, are said to be parallel if their cross product so in this case here, we're looking at the cross product, okay? So if the cross product is what? A 0 vector. So if the cross product is 0, then it is said to be, the two vectors are said to be parallel. So that means A and cross product with B is going to give you what? 0. So when the cross product is B, it's going to give you 0, okay? Now, the next one, number 5, let's talk about the dot product. So the dot product, that is very easy because you know that it is magnitude of A, magnitude of B, cos theta. And because the theta is 0, cos 0 is going to give you 1, right? So that means the dot product should be equal to the magnitude. Is that okay? So that is the difference here. If it was a cross product, it's going to be 0. But if it's the if it's the dot product, it's going to be equal to the product of the magnitude. But if it's a cross product, it's going to give you 0. So we have two vectors, A and B, are said to be parallel if they are dot product. Now we're looking at dot product. Is equal to the product of their magnitudes. So we already know from the previous video that A dot B is equal to the magnitude of A, magnitude of B cos what? Theta. But we now know that theta is equal to 0. So, but theta is equal to 0, okay? Then, therefore, cos theta, cos 0 is equal to what? 1. So if all this now is equal to 1, so we can now say that A dot B will be equal to the magnitude of A and the magnitude of B. So that's why we say for dot product of two parallel vectors is equal to the product of their magnitude. All right, so these are the 5 properties. So we've talked about the properties, we've talked about all these concepts together. So we've already talked about the properties for both of them. We talked about the properties for the dot product. We've talked for the cross product. We've also said that if two vectors are parallel, they are parallel to themselves. Same direction, k is greater than 0. opposite direction k is less than 0, and two vectors are parallel only if they have a scalar quantity k, okay? And also I talked about that there's no angle between parallel vectors. The angle is equal to 0. And also we have to talk about the scalar multiple. And also same direction is going to be the same, and opposite direction is going to have they're still the same, but they can either be in the same direction or they can be in opposite direction. So technically, we just spoken about an overview, all right? So this is an overview of parallel vectors. Now, the next video, we're going to check on how to find parallel vectors. So the next video, we're going to talk about how do we find parallel vectors. So it's very important you click the notification bell so that when I post the next video, you'll be the first person to know, all right? Please, if you have any question, send me an email, or you can also reach me, or you can stop me anywhere you see me, and I can explain several concepts to you, all right? All right, I'll see you soon in the next video where we talk about how to find parallel vectors.